All right, so we're going to be looking at a sample of the SBA. So a number of persons have been requesting a sample of a mathematics SBA as a guide. This SBA is intended to be a sample guide and should not be copied and submitted as your own. All right, now here we have the SBA title. All right, so here the title is saying, does it take longer to run 50 meters on the curved part of a track than it takes to run the same distance on the straight? All right, so all of this here would give the title of your SBA. So this is the SBA title. All right, so you should have your title, right? And this title comes in the form of a question. And remember, say that the title can be either as a question or as a claim. All right, now the next part of your SBA has to do with the introduction. So your introduction, this is your introduction. So let us see how this was introduced. So this introduction now gives you a background idea of what you're doing, right? So here we go. One of the most exciting events in the field of athletics is the 4x100 meter relay. This event is a team event and much care and strategy goes into choosing the right person for the right leg. Athletes are chosen based on their ability to run the curve, the straight, or their ability to hand off or receive the baton. Some athletes prefer to run curves while others prefer to run on the straight. This SBA will attempt to discover if it takes longer sorry guys, where am I now? So this SBA will attempt to discover if it takes longer to run the same distance on the curve or the straight part of the track. All right. Now, what you notice here in your introduction, the introduction gives you kind of a background information of what you're trying to do. So you notice that your title relates to the introduction. So it kind of gives a description of what running a race is like, what are the dynamics, what are the things that you need to consider. So it gives you all of that. And then now, at the end or the last sentence here, you notice that it tells you what the SBA is investigating. What is it that you're trying to find out, right? So this SBA will attempt to discover if it takes longer to run the same distance on the curve or the straight part of the track. So this now would go back in relation to what you have with your title. All right, so that is your introduction. Now, the next part of the SBA then will reflect your method of collecting data. All right. Here you have this, the student researcher will ask 20 classmates during PE time to run 50 meters on the curve, 50 meters on the curved part of the track. They will all be using the same line. Each person's time will be measured using a stopwatch, rounded off to the nearest 10th of a second, and the time will be recorded. those same persons on a separate PE class time will be asked to run the 50 meters on the straight part of the track. The result will be measured in the same way as the distance on the curve and recorded. The two sets of time will be compared and analyzed. So this part that we just look at gives a description of how the methods that they intend to use to collect the data, right? And so they tell exactly how they're going to compare the data. So you're going to have one event. They're going to run the curve, and then now the time would be measured. So how many students are going to use? They're going to use 20. So for each of these students, they're going to record the time. So obviously they will have to put all of the time now in some table. All right. And then now on another day, they're going to use the same students again to run the straight and then measure the time. So same 20 students. So all of the data now going to be collected and analyzed, and they're going to compare which one of them is faster. Because based on what this is trying to find out, the SBA want to discover, they want to discover if it takes longer to run the same distance on the curve or on the straight, which one of them is longer to run. So your method of data collection should tell exactly how you go about collecting that data. All right, after you do your collection of data, next thing you want to look at your presentation of data. So the table below shows the data. And remember, we say that you have to introduce your table. So this is what the introduction of a table would look like. So the table below shows the data collected for the time taken to complete 50 meters on the curve and on the straight. The students here have been labeled using letters and not their unique name. So now what we should see is a table reflecting what the introduction have here. So the introduction of the presentation given up here. Now the table, so they introduce the table, and the table is given here. And as it was stated, then the student would be used, the name of the student will be represented by letters of the alphabet instead of their names. And so it's 20 of them. And so you should have the time they run on the straight. So all of these students here have their time measured running on the straight. The same set of students have their time measured running on the curve. All right. Now, down here now, it said that the histogram below shows the time taken to complete 50-meter run on the straight part of the track. And so majority of the athletes finish the race within 7 to 8 seconds. So here now, there's another chart that gives a bar chart of the data. All right. Now, the data in this form is like a graph. You have a vertical axis. You have a horizontal axis. Now, the horizontal axis, you record the time. So these are the time in this column. The height of the bars, though, is based on the frequencies. So the vertical bar, the vertical axis give you the frequency, all right? Now, here, this histogram gives you the time in terms of what we call class intervals, right? So they tell you what is the time generally that you have from 6 seconds to 6.9 seconds. So the set of students who run within that time would be two students run within that time. From 7 seconds to 7.9 seconds, 14 students run within that time. From 8 to 8.9 seconds, 2 students run within that time. From 9 to 9.1, 2 students run within that time. Now, what you want to do now is to show this on this chart. So the frequency, so from 6 to 6.9, this would be your frequency. The frequency is 2, so the bar would go up to the height of 2. Right, so the height of this bar is 2. And from 7 to 7.9, 14. So the height of this bar goes up to 14. Right? And from 8 to 8.9, the height of this bar goes up to 2 again. So it just goes up to this side. And the other one also goes up to this side. Now, when you look at this histogram, you're looking at the bars, and the bars, they say a picture worth 1,000 words. So if you look at these bars, you're just looking at the height of them and comparing which of them is the tallest. So the one with the tallest height represents the one that has the most persons running within that time, right? So just looking at this bar, you see that from 7 to 7.9 seconds, you have most of the students running in that time, right? So these are things that you're looking for in your analysis. So you have to say what it is that you're seeing based on the chart or the graph. And so you are going to make reference to that. So here you could refer to the height, and this is what it have here now. So let me clear this. All right, so the histogram below shows the time taken for a student to finish a 50 meter on curve. The histogram shows. So now here now there's this other chart, which is another histogram. This one now is for the curve. The one above would have been the histogram for the straight. So this, what you can do, you can compare the two histograms, and now you compare the time and say which one of these histograms shows that they move faster on. So if you look at the time here, how many persons run the time from 7 to 7.9? You're going to have 3. Now, remember now, when you compare the two tables, you see that you're going to have 2 different times. And so in your analysis, you need to point out these differences, why the time are differences, and say why they are different. What you think caused it, why they are different, right? So it means that if the lesser the time it takes, because here if you run 6.69, it means you take less time to run. You take less time, so the amount of person who run it at a shorter time would be 2. Majority of the people run it at this time, and the people who take the longest time would run it for 8.89 and from 9 to 9.9. So when you look at these two charts, you can compare the time from both of them, and you can see why the time would be the same for the different intervals or why they would be different. So that is how you would compare your charts. So the comparative bar chart below shows the time side by side for each athlete who complete the two events. So down here now is another chart that merge the two charts that you have above. They merge them together. So you have two different separate bars. You have bars in red or burgundy, and you have bars in blue. So the bars in blue would give you either, one going to give you on the straight, one going to give you on the curve. Now, the line graph below, so you should be able to determine based on when you plot your bar, which of these would be the curve and which of these would be the straight. But if you use something like Excel, you could label your axis. So on the label of the axis, you notice that you have time in seconds to the nearest 10th. And down here now, you have on the x-axis, the names of the individual in terms of letters of the alphabet. On the side here, you see you have the color code. The blue represent those who run on the straight, and the burgundy and red represent those who run the curve. So A, when you look at the blue and the burgundy for A, you notice that the burgundy is slightly higher. Now, the fact that the burgundy is higher means that it takes more time, because remember, the time is on the vertical axis. So clearly, if you look at all of these bars, you see that the burgundy is higher. Now, the burgundy represents that you're running on the curve. So if the burgundy is higher, it means that you take longer time running on the curve. The blue is shorter, so it takes less time running on the straight. So when you look at this chart, you could clearly see burgundy taller, meaning that it takes more time to run the curve than it is running the straight. So looking at this, that you're taking this information from the diagram, that would be a part of your analysis. Now, so you use this chart to make your comparison. You can also use another chart to make your comparison. So this is another chart that is used comparing the two, and both of them is showing similar things, because on this chart, you see that the burgundy line is above the one, the blue line. The burgundy line run on the straight. No, the burgundy line run on the curve, and the blue line run on the straight. So the fact that the burgundy line is above it means that the time is greater when you're running on the curve than when you're running on the straight. All right, this is an example now of how they analyze the data. So the analysis of the data. The 50-meter straight run had a range of 2.7 seconds. This means that it took 2.7 seconds for all the athletes to cross the finish line once the first person had crossed. Now, all of this information that they are going through in the analysis would have come from both the table and the table with in terms of the data. Now, from 7, if the range of from 7 to 7.9, if you take away 7 from 7.9, you will get a time range, right? So if you take away around 7.9, you would have about 0.9 seconds. So they're saying, based on these tables, if you look at the different ranges of time, the time would have ranged from, it would have a range of 2.7 seconds. Now this means that it took 2.7 seconds for all the athletes to cross the finish line once the first person had crossed. Now the 50-meter run on the curve had a range of 3.3, which is 0.6, which is 3.3 seconds longer than the straight. Now the average time it takes to run the 50-meter straight is given as 7.69 seconds. The average time to complete the 50-meter run on the curve is calculated as 8.56 seconds. So on an average, it took 0.87 seconds longer to complete the 50-meter run on the curve than it took to complete on the straight. So the average speed taken complete the 50-meter run on the straight was calculated using the formula. And this shows that the speed on the straight was 6.5 meters per second compared to 5.8 meters per second on the curve. So the average speed over the 50-meter straight was faster than the curve, than on the curve. All right, so this is an example of the analysis. So what you notice about the analysis is that the same information that you have on your charts, that's where you're taking your data and comparing them. In your analysis, you're comparing your data. Now, your data doesn't have to look like this because your SBA might not be doing the same thing. But the idea is whatever the chart that you create, you should be able to speak on what the data represents from your chart in your answer, right? So it's in your analysis. Now, after you have done your analysis, then now you want to have a discussion. While it was expected, based on the observation of especially 4x100-meter relay, where the curves become very critical, that it would take longer time to run the curve than on the straight, it needs to be pointed out that in an actual relay, the person running the third leg will often run just as fast as the person running the second or anchor leg, since those persons do not use a cold start out, of the block. Now the data shows that if both start a cold, if they both start off the blocks, then it takes a longer time to run 50 meters around the curve than on the bend. While in some cases, there is a very small difference, the fact remains that there was a difference. All right, now in conclusion, this SBA started with the assumption that it takes longer to run 50 meters on the curve part of a track than on the straight. Assuming that both cases are cold start is used, the data showed beyond doubt that it does indeed take a longer time to run the curve. All right, so that's the conclusion. So you notice that the conclusion is short and to the point. It tells you whether or not what you claim is what you actually find out, or if it is not, right? Then now you have your appendix. The appendix now would put what you are expected to have here. You are expected to have diagrams, mathematical knowledge used, the standard track and so on. So this gives you an example of what you find in the appendix. So these would be supplied data that you can put in your appendix. So other things that you could put in your appendix is like the instrument that you use to collect your data, like your survey and so on. You put those in the appendix. And so this gives you an example of a layout of how your SBA should be done. All right. Is there any question in regards to what you're expected to do? Ms. Waysam, are you clear as to what you are supposed to be doing?
So far, yes, I think my group would be on the right track based on what we have done so far, sir. But I would feel a little more. Are you hearing me, sir?
Yeah, I'm hearing you, but I didn't hear what you said.
No, I'm saying that so far, I think my group,
yes,
we're on the right path, but we would feel a lot more safer, sir, if you could have just give me a little perusal. But just peruse a little bit on where we're at.
I will, but just try to put it together as much as possible first. So I want a first draft, kind of a complete draft that I can look over on. I don't need dissecting it piece by piece. I want to just look at the overall thing and see how well it is coherently put together. All right?
Yes, sir.
All right. Ms. Clark, do you have a better idea of what you're doing now?
Yes, sir.
Okay. And so does this help you to further organize and collect your data?
Yes, sir.
Okay. All right. Mr. Campbell.
Yes, sir.
You're part of any of the SBA team. Do you already have an SBA or do you doing one currently?
I'm doing one currently, 1 month army still.
Okay. And how is it going with your group?
It's basically 1 man army, sir. I guess they already had SBA that they're going to use already, so
so you're saying the other persons are not doing the SBA?
No, they done SBA already, so they said they don't.
Are they offering any assistance to you?
No, sir. I'm being honest now.
No, but the point of having the group is either to get some kind of support or guide. So if it is that you're not getting enough support there, what is your topic? You started anything already?
Yes, sir. It's a higher purchase question. It's cost price because higher purchase.
Okay. Are you feel comfortable doing that question and by yourself?
Yes, sir.
All right.
Yes, sir.
All right. No problem. Once you feel like you can get it together within the time frame. All right. All right. So in general, students, is there any question or concern that you have that you like me to address? I'm going to stop recording now.